Oh shit. Here we go again.
I'm here. I made it. Buttercup made it. Buttercup, it's just your butt. Come here. Come here. It's Butters. She said hi. Hello. Ooh. Okay, so I've been away. I got the rhinovirus apparently, and that exacerbated some returning childhood asthma. So I had an asthma attack. We've been recovering, but I'm still a little sick, so maybe sounding congested. I may cough. I'll try to mute the mic if I need to cough. We also have Minmo if it's really bad. But yeah, I'm hoping, I know this is gonna be a lot of reading. I'm hoping it's maybe a little bit like episode of Friends with Phoebe when she's sick. And she's just trying to get sick again, so she has her sexy six voice, It's just that one episode. It'll be good, Okay, well, let's get into it. I think we actually should start with typing. We're rusty. We are rusty. All right. I think we're just going to get right into it. I like that we do this first one each time. So it's like my sticky shoes. Thank you. I couldn't remember what she sings. Yeah, this is going to be like a constant if we just do this one typing test each time. So it's once we get better, then we can move on to the next test. But I like that it does start here, So how y'all? It's been a while. I had so much fun with Lands of Lore. I'm wanting to go live again tomorrow. Get a little further with that. I don't know if we need to go back. Maybe. And you know what? Maybe we just get the ending we get. I might go back a little bit to the beginning of that cave and just turn around, because I don't think we were ready for it. I don't care about anything we got in there. I just want to get out. I don't remember what our last time was, but I like to compare start of the stream to end of the stream more than separate days. It's just a good warm-up to get my brain in the mindset of what we're going to be doing, I think. I keep looking at the keyboard and I'm not meant to, but all right, I'll stop. Well, no, I can't stop. Jesus. Keep looking. I'm okay, I'm not gonna move my head, and then my eyes just boop. like a reflex. It's difficult. Ooh, that was nice. I didn't look at the keyboard then. Writing engines. Ooh, I do like being able to type without looking. It does feel like almost like my brain isn't doing it, my hands are, you know? And then it feels like my brain can relax, ironically. Ah. A? Where'd you go, A? This one's nice, this song. Go. 21. I'm pretty sure we were under 20. Okay. 21. 21. All right, we'll do this again at the end. So, we are at chapter 2.5, Introduction to Local Scope. All right. Local variables. Variables defined inside the body of a function are called local variables, as opposed to global variables, which we'll discuss in a future chapter. Okay, let's get back in it. We got an integer. Okay, so this is a local variable, I'm assuming, of add, and we're asking it to add these two. No, z is a local variable. Whoops. We're getting into it. We're getting right back into it. All right. Right, so z has been initialized as x plus y. Please return what z is. Okay. Interesting. Function parameters are also generally considered to be local variables, and we will include them as such. Okay. Function parameters x and y are local variables. So, okay, they were. Okay, add was not, but these are local variables. Gotcha. In this lesson, we'll take a look at some properties of local variables in more detail. Local variable lifetime. In lesson 1.3, Introduction to Objects and Variables, we discussed how a variable definition such as integer x causes the variable to be instantiated when this statement is executed. Function parameters are created and initialized when the function is entered, and variables within the function body are created and initialized at the point of definition. For example, x and y created and initialized here. Z is created and initialized there. The natural follow-up question is, so when is an instantiated variable destroyed? Local variables are destroyed in the opposite order of creation at the end of the set of curly braces in which it is defined, or for a function parameter at the end of the function. So I'm assuming once it gets to here, it's like, all right, dump it. Give it what that wants, and then we're dumping this information, right? Z, y, and x are destroyed here. Much like a person's lifetime is defined to be the time between their birth and death, an object's lifetime is to be the time between its creation and destruction. Note that variable creation and destruction happen when the program is running. Okay, sorry, real quick. There's a thunderstorm out, so the doggies are a bit on edge. It's okay. You're good. It's another, like, window rattling thunderstorm. Get up there. Buttercup, you're in the way. She can't get up because you're in the way. Go, go, go. Up. Ready, up. You can do it. You're so brave. You can do it. Ready, up. Up. Ready, up. Hello? Woo! Oh my gosh. Martian Labs? She jumped up for you. How you doing? Thank you for the follow. Okay. Sorry, we were in the middle of a sentence, but hello. She started fussing. Okay. Much like a person's lifetime is defined to be the time between their birth and death, an object's lifetime is defined to be the time between its creation and destruction. Note that variable creation and destruction happen when the program is running, called runtime, not at compile time. Therefore, lifetime is a runtime property. Okay. Yes, welcome. How do you do? I have a bit of a cold, so please pardon me already. Alright, for advanced readers, the above rules around creation, initialization, and destruction are guarantees. That is, objects must be created and initialized no later than the point of definition and destroyed no earlier than the end of the set of the curly braces in which they are defined, or for function parameters at the end of the function. In actuality, the C++ specification gives compilers a lot of flexibility to determine when local variables are created and destroyed. Objects may be created earlier or destroyed later for optimization purposes. Most often, local variables are created when the function is entered and destroyed in the opposite order of creation when the function is exited. We'll discuss this in more detail in a future lesson when we talk about the call stack. Ooh. Here's a slightly more complex program demonstrating the lifetime of a variable named x. Okay. We're going to character output hello. And we got our main. And we got x is 0. X's lifetime begins here. Do something. X is still alive during this because he's inside these braces. And also, please return 0. X has died at this curly brace. Yes. In the above program, the lifetime of x runs from the point of definition to the end of function main. This includes the time spent during the execution of function do something. What happens when an object is destroyed? In most cases, nothing. The destroyed object simply becomes invalid. For advanced readers. If the object is a class type object, prior to destruction, a special function called a destructor is invoked. In many cases, the destructor does nothing, in which case no cost is incurred. We introduced destructors in lesson 15.4. Okay, that's far. Any use of an object after it's been destroyed will result in undefined behavior. We don't want that. At some point after destruction, the memory used by the object will be deallocated, freed up for reuse. I have a Maddie here. Oh no. Oh no. Hello, another follow. Cravat TV? Thank you. I don't know if I should do, I was thinking about doing anonymous follows. I know that's a lot comfier for people, but I don't know, I like saying hello. And you don't have to say it back. All right. Local scope. Block scope. Love lurking. Okay, well, we got follow emotes for the lurkers. Here we go. Okay. Local scope. Block scope. An identifier's scope determines where the identifier can be seen and used within the source code. When an identifier can be seen and used, we say it is in scope. Okay. When an identifier cannot be seen, we cannot use it, and we say it is out of scope. Scope is a compile time property, and trying to use an identifier when it's not in scope will result in a compile error. So if X has died and you're out of the scope and you try to use X again, it's going to be upset. The identifier of a local variable has local scope. And okay. Oh, thank you. Yeah, we just got our dogs and we're just trying to burn through this, really. Thank you for saying I seem normal. Just kidding. All right, let's see. I need to reread this. The identifier of a local variable has local scope. An identifier with local scope, technically called block scope, maybe I didn't read this, is usable from the point of definition to the end of the innermost pair of curly braces containing the identifier, or for function parameters at the end of the function. This ensures local variables cannot be used before the point of definition, even if the compiler opts to create them before then, or after they are destroyed. Local variables defined in one function are also not in scope in other functions that are called. Here's a program demonstrating the scope of a variable named X. X is not in scope anywhere in this function. X has not been even called. X cannot be used here because it's not in scope yet. X enters scope here and can be used now within this function. Okay, because X has been initialized finally. Even though it's within the curly braces, it hasn't been initialized yet, so it can't be used here. And then it's out of scope once it's destroyed. No, it's fine. These are like really chill. The streams are what keep me like accountable, like keeps me actually coming back to reading it. If I was just sitting alone, I probably would be like, you know what, I'm done. Do you need uppies? What do you need? She's fussing, I don't know. I'm gonna pick you up. Anyways, I don't know, like you're not distracting me, Buttercup is. She's found there's some pizza we didn't finish eating I need to put away, and she's like, I need that pizza. She won't go. She wants the pizza. I will, I think. Give me a minute. Yeah, the main biggest goal after we're done with all this and learning C++, we're going to be doing then like Unreal tutorials and things, so that'll be fun. But I want to feel very confident as far as programming and being able to at least read the language. I think we'll get to that point, and I don't know, I think maybe we're going a little too try-hard trying to finish this whole thing before we start Unreal lessons, but I just feel like I'd be more ready for them. What is she doing? Oh, I keep looking the wrong way. I keep forgetting it's flipped now. What? Okay. Well, let's get back in it. Out of scope. No, wait, whoops. In the program, variable x enters the scope at the point of definition. X goes out of scope at the end of the innermost pair of curly braces containing the identifier, which is the closing curly brace of function main. Note that variable x is not in scope anywhere inside the function doSomething. The fact that function main calls function doSomething is irrelevant in this context. No, literally, like, I'm 31, and I'm like, okay, I know I'm just like now starting. So it's like, we've been doing, because I'm only meant to do my self-inflicted rules is coding streams on Tuesdays, but we've been trying to do bonus streams on Saturday to try to like fit in more lessons. 31, oh my god, everyone, we're in our 30s here, let's hang out. English is second language. You're doing very well. Very good. It's like, it's never too late to start. Like, every year that passes, you know, it's another year that I could have been learning. So now's the time. Yes. And we also have, like, I have coding sections, but I haven't really done anything. Argentina. Oh my goodness. Oh, this is so fun. Yeah, we have a Discord. I think you could do ! Discord. Or I have, hello, socials. Maybe that works. Okay. I can't see with my sunglasses though. Stream Deck. Let's see. Oh, thank you so much. Oh my gosh. Awesome. Okay. Out of scope versus going out of scope. Oh. The terms out of scope and going out of scope can be confusing to new programmers. An identifier is out of scope anywhere it cannot be accessed within the code. In the example above, the identifier X is in scope. What? The identifier X is in scope from its point of definition to the end of main function. The identifier X is out of scope outside of that code region. Oh. The term going out of scope is typically applied to objects rather than identifiers. We say an object goes out of scope at the end of the scope, the end of curly brace, in which the object was instantiated. In the example above, the object named X goes out of scope at the end of the function main. Oh, I love that. Thank you. Yeah, I feel like honestly, it was a little I'm trying to think about how to phrase this. I'm wanting more of a female audience. I feel like women in STEM needs to be a stronger thing, you know? HTML. That's HTML I'm strongest with, really. That's like what I use for work, so it's kind of useless a little bit. Yeah, honestly, I'm feeling like I can do this now because I have my ADHD medicated now, you know? I'm like, okay, I could focus, like I could actually like keep at it. Yeah, I have very little experience. I took a Java class and I didn't really feel like I learned too much besides a lot of, to be honest, I'm learning way more through this. Like I feel like I'm getting like the fine details of like what's going on in the programming, whereas with Java it was just like, here's a if then, do some loops, and it's just like, okay, that worked, it gave me the output I needed, let's go on to the next project so I can pass this class, please. And then I was so frustrated. They had us take a like simulation and gaming class, and it was for Unity, which needs C#. And I'm like, why was Java what's required, but I need to know C# to do this Unity class? Oh my god, I love that. I would love that. All right, let's see. Out of scope and going out of scope, because I'm just like not picking it up. An identifier is out of scope anywhere it can't be accessed. So when it's out of the curly brackets. The identifier X is out of scope outside of that code region. I think code region is where I got scared. I was like, what do you mean? The term going out of scope is typically applied to objects rather than identifiers. Okay. We say an object goes out of scope at the end of the scope, the end curly brace, in which the object was instantiated. In the example above, the object named X goes out of scope at the end of function main. A local variable's lifetime ends at the point where it goes out of scope, so local variables are destroyed at this point. Note that not all types of variables are destroyed when they go out of scope. We'll see examples of these in future lessons. Example. No, honestly, like, once I was in the class, they were like, like, if you know C#, it'll help, but, you know, there was like one chapter on scripting. So I tried to give like the base level, like how C# works. But then I was like, I don't even want to learn C#. Like, it was just frustrating. I just needed that degree and I needed to get out of there. Let's see. Another example. Here's a slightly more complex example. Remember, lifetime is a runtime property and scope is a compile time property. So although we are talking about both in the same program, they are enforced at different points. Okay. Well, we're just reading through it, and then this website is honestly incredible. I was like, I had to make sure I have the watermark there because this website's great. Usually at the end of each chapter, there's like quizzes to see like what we've retained, and then towards the end of like whole sections, they have a lot more projects. Like, actually, like, okay, we want this output, you know. It's learncpp.com. It's completely free. I love it. I love it so much. Okay. So it's like they literally have just like, let me just show you. Oh, not the index. Whoops. This is all of the lessons. And it just keeps going and going. And this is all free. And it gets updated. It was updated January of this year. I have definitely been on there for like HTML stuff when I need help with that. The answers are usually there when I'm like, why is this color not changing? But yeah, it's wild. Okay. X and Y are created and enter scope here. Okay. They're usable only within add. Y and X go out of scope and are destroyed here. A is created, initialized, and enters scope here. Right. Oh my God. What was it? There was something I was working on the other day, and it was actually hours of like website editing, or like, I don't remember exactly what was happening, but the page was not looking right, and it was literally just like a semicolon or something. I wanted to throw up. But there was like, then there's also the relief of just like, it was just a semicolon, like, we're okay. Everything's okay. We can go back to breathing again. Okay. A is created, initialize, and enters the scope here. B is created, initialize, and enters the scope here. A and B are usable only within main. Character output. Add A and B. Calls add 5, 6, where x equals 5 and y equals 6. Okay, because this is still within the curly braces, it's still active. It literally is, yeah. I wonder if that's like where like people get really sucked into programming, like there's like the high of it, you know? That I gotta solve that puzzle. Let's see. I'm definitely feeling it like with these lessons. Like when we do a project, it's like we've been doing them, and obviously we're on chapter 2, so it's not super advanced, but when it's like, okay, we want this output, we'll write the code. And I'm a bit of a perfectionist, so I'm like, okay, we're gonna get this exactly how they told us it needs to be. And then when we reveal the answer and it's exactly the same, it's just like, yes, like we did it. Like it's so perfect. Okay, they're destroyed. I feel like this is the third time they've explained. I feel like we just keep going over the same thing of when things are made, they're then destroyed. Right? Is this being reiterated, or am I missing new information? Yeah. Okay. Parameters x and y are created when the add function is called. Can only be seen used within function add and are destroyed at the end of add. Variables a and b are created within function main and can only be seen used within function main and are destroyed at the end of main. Please, to enhance your understanding of how this all fits together, let's trace through this program in a little more detail. The following happens in order. Okay. Execution starts at the top of main. Main variable a is created and given value 5. Main variable b is created and given value 6. Function add is called with argument values 5 and 6. So it's asking, please add a and b, which are 5 and 6. Add parameters x and y are created and initialized with values 5 and 6 respectively. The expression x plus y is evaluated to produce the value 11. Add copies the value 11 back to caller main. Add parameters y and x are destroyed. Okay. Main prints 11 to the console. Main returns 0 to the operating system. Main variables b and a are destroyed. And we're done. Okay. It's interesting. It's almost like the 0. Okay, never mind. The 0, returning the 0 is just more for us so that we can see, like, yep, we got a 0. It got to the end of the code. That's not necessary for things to be destroyed at the end. Just that ending curly brace does it. Note that if function add were to be called twice, parameters x and y would be created and destroyed twice, once for each call. In a program with lots of functions and function calls, variables are created and destroyed often. Functional separation. In the above example, it's easy to see that variables a and b are different variables from x and y. Now consider the following program. I'm like leaning this way so I can like see better, but then I'm like not in the microphone. So sorry. Let's see. Now consider the following similar program. Adds x and y are created and enter scope here. Adds x and y are visible and usable within this function only. Adds x and y go out of scope and are destroyed here. I really feel like they're like hammering this home. Like, it's created, enters scope, they're usable, calls it, and then it's destroyed. In this example, all we've done is change the names of variables a and b inside function main to x and y. This program compiles and runs identically, even though functions main and add both have variables named x and y. Why does this work? First, we need to recognize that even though functions main and add both have variables named x and y, these variables are distinct. The x and y in function main have nothing to do with the x and y in function add. They just happen to share the same names. Second, when inside a function main, the names x and y refer to main's locally scoped variables x and y. Those variables can only be seen and used inside of main. Similarly, when inside function add, the names x and y refer to function parameters x and y, which can only be seen and used inside of add. In short, neither add nor main know that the other function has variables with the same names, because the scopes don't overlap. Okay, I am understanding new information from this. It's always clear to the compiler which x and y are being referred to at any time. Oh, that's so nice. Yeah, no, I love that. That'd be so nice. Thank you so much for joining the Discord. I feel like I try to push it a little bit, but I can't get a lot of people to join. But the main thing I want the Discord for is coding reasons. Like, I want people to like, hey, I'm like trying to work on this and it's not like, can I get another pair of eyes on it, or like, you know, stuff like that. Key insight. Names used for function parameters or local declared in a function body are only visible within the function that declares them. This means local variables within a function can be named without regard for the names of variables in other functions. This helps keep functions independent. We'll talk more about local scope and other kinds of scope in a future chapter. Where to define local variables? In modern C++, the best practice is that local variables inside the function body should be defined as close to their first use as reasonable. What? Should be defined as close to their first use as reasonable. X is defined here and used here. Like, don't define it and then use it like way down here. Okay. Enter another integer. Y is defined and used here. Some can be initialized with intended value. Okay. In the above example, each variable is defined just before it is used. There's no need to be strict about this. If you prefer to swap lines 5 and 6, that's fine. 5 and 6. I do, actually. I don't know why. I felt like they taught it to us first to initialize and then character output. I like to have like it ready to go before it even asks for it, you know? Oh my god, yeah. I only use AI when I'm like, why did this happen? Or like explain something to me. But it's also, I can Google it and it can be explained as well. AI is part of the bigger reason that I'm like, I just want my manual coding to be really clean and good without the AI crap infiltrating, you know? It's a tool, and it needs to be used as a tool, not as the whole ass thing, you know? Best practice. Define your local variables as close to their first use as reasonable. I understand what's being said now. Okay. As an aside, due to limitations of older, more primitive compilers, the C language used to require all local variables to be defined at the top of the function. The equivalent C++ program using that style would look like this. Interesting. Whoa, so you like initialize this, and this, please. And then character output for what is X, what's Y. That is weird. C language. Okay, so this is not C++. I said aside. Whoops, I'm not reading. I was just like, what is this? So in just regular C, it's all got to be put at top. Okay. Suboptimal for several reasons. The intended use of these variables isn't apparent at the point of definition. You have to scan through the entire function to determine where and how each variable is used. Yeah, ooh, I would not like that. The intended initialization value may not be available at the top of the function. We can't initialize sum to its intended value because we don't know the value of x and y yet. There may be many lines between a variable's initializer and its first use. If we don't remember what value is initialized with, we will have to scroll back to the top of the function, which is distracting. This restriction was lifted in the C99 language standard. Okay. Yeah, and honestly, like, I have no idea where they got it from. I have no idea if they're right. You know, is it putting in vulnerabilities into my code and then just gonna start spreading it around everywhere? Like, it's what AI is like snake eating its own tail or something, like. All right. When to use function parameters versus local variables. Because function parameters and local variables can both be used within the body of a function, new programmers sometimes struggle to understand when each should be used. A function parameter should be used when the caller will pass the initialization value as an argument. A local variable should be used otherwise. What? A function parameter should be used when the caller will pass val is a function parameter. Using a function parameter when you should use a local variable leads to code looking like this. Enter a value, return value. What am I looking at? I'm like, what? X, get value from user. Okay. Function's being pulled here. So X will be whatever this pulled, which is value. So then X is value. Okay. And then num is that? Like, wait, I'm confused now. In the above example, get value from user has defined val as a function parameter. Because of this, main must define x so that it has something to pass as an argument. However, the actual value of x is never used, and the value that val is initialized with is never used. Making the caller define and pass a variable that is never used adds needless complexity. The correct way to write this would be as follows. Okay, return value, get value from user, that's different. Yeah, there's no x. Num is get value from user, so just num. Yeah, we didn't need the x there. Oh, goodness. It was so great to meet you two. Thank you, and I'd love to see you back. And yeah, I will probably hit you up. That would be very nice to more motivation to keep going, you know. Let's see. Is that really all that's different? It's just like we didn't need to even call it x. Like, why did we? We initialized x, told it was x, but we didn't need to do that at all. In this example, val is now a local variable. Main is now simpler because it does not need to define or pass a variable to call. Denmark, whoa. I know too many people from Denmark. Well, have a good night. Nice meeting you. Best practice. When a variable is needed within a function, use a function parameter when the caller will pass the initialization value for the variable as an argument. Use a local variable otherwise. Introduction to temporary objects. A temporary object, also sometimes called an anonymous object, is an unnamed object that is used to hold a value that is only needed for a short period of time. Temporary objects are generated by the compiler when they are needed. There are many different ways that temporary values can be created, but here's a common one. Return the value of input back to the caller. So what is the input? Where does the return value get stored? I'm not sure. In the above program, the function getValueFromUser returns the values stored in local variable input back to the caller. Because input will be destroyed at the end of the function, the caller receives a copy of the value so that it has a value it can use even after input is destroyed. But where is the value that is copied back to the caller stored? We haven't defined any variables in main. What? Oh, we haven't. The answer is that the return value is stored in a temporary object. This temporary object is then passed to character output to be printed. Well, thank you. Key insight. Return by value returns a temporary object that holds a copy of the return value to the caller. Temporary objects have no scope at all. This makes sense since scope is a property of an identifier, and temporary objects have no identifier. I have to cough, so I'm going to mute my mic. We're back. Okay. Temporary objects are destroyed at the end of the full expression in which they are created. This means temporary objects are always destroyed before the next statement executes. In our example above, the temporary object created to hold the return value of getValueFromUser is destroyed after character output getValueFromUser executes. In the case where a temporary object is used to initialize a variable, the initialization happens before the destruction of the temporary. In modern C++, especially since C++ 17, the compiler has many tricks to avoid generating temporaries where it previously would have needed to. For example, when we use a return value to initialize a variable, this would normally result in the creation of a temporary holding in the return value, and then using the temporary to initialize the variable. However, in modern C++, the compiler will often skip creating the temporary and just initialize the variable directly with the return value. Okay, it'll just like go straight, like here it is, right? Similarly, in the above example, since the return value of get value from user is immediately output, the compiler can skip creation and destruction of the temporary in main and use the return value of get value from user to directly initialize the parameter of operator. Extractor operator? Is that what it is? Quiz time. Okay. What does the following program print? Okay. Do it. So X is 4. This is funny. Now I'm all confused. I'm like, huh? Let's see. Like, I'm just confused because it's like output what X equals. What does X equal? We haven't even, X equals 3, but why I think it's going to be upset. It's going to try to pull it, but it hasn't been in stage. Is that the quiz? Is it this trick question that the output would be like a compile error? Or am I not? Because I know that int is X, or what? No. I'm so confused. X is 1, Y is 2. Okay, so those are initialized. Output that X is 1 and Y is 2. And then do it. See, this is gonna be gross too, right? They don't like that. They're doing the X because then it's calling this X inside here. Like, this is a mess, right? Am I wrong that this is a mess? I don't know what it's gonna output. I can't really say because it's just don't look right. Here's what happens in this program. 1, 2, main, do it, main. 1, 2, 1, 4, 3, 4, 1, 2, 1, 2. Where are you even getting that? 1, 2, main. Good God. Okay, here's what happens in this program. Execution starts at the top of main. Music's what's going on in my head right now. All right. Didn't realize that. Main's variable X is created and initialized with value 1. So we're starting here, so X does get initialized. And then Y is initialized with 2. I understand now, because then once we get to do it, then it's like, wait, what's do it? Oh yeah, do it. Let me run this real quick. We're rusty. That's what happens when you get sick. Okay. Literally me right now. Alright. Character output prints main x equals 1, y equals 2. Do it is called with argument 1. Oh. Do its parameter x is created and initialized with value 1. Do its variable y is created and initialized with value 4. Do it prints do it x equals 1, y equals 4. Do its variable x is assigned the new value 3. Character output prints do it x equals 3, y equals 4. Do its y and x are destroyed. Character output prints main equals x equals 1, y equals 2. Main returns 0 to operating system. Main's y and x are destroyed. Note that even though do its variables x and y had their values initialized or assigned to something different than main's x and y were unaffected because they're different variables. I'm like, oh, we run the code from top to bottom. Like, what is happening? We start at main, and then it will call whatever functions we have at the beginning. I recall now. Alright, I think we're gonna do a BRB, and then we'll get going on this one. It's already kind of late. Let me see how long this one is. Oh! Okay, maybe we should just read this real quick. Right? Let's read this and then I'll do a BRB. 2.6. Why functions are useful and how to use them effectively. Now that we've covered what functions are and some of their basic capabilities, let's take a closer look at why they're useful. Why use functions? New programmers often ask, can't we just put all the code inside the main function? I do feel that sometimes. I'm like, why can't I just... Like, I guess like HTML, but even with that, still need functions and CSS and things. For simple programs, you absolutely can. However, functions provide a number of benefits that can make them extremely useful in programs of non-trivial length or complexity. Organization. As programmers grow in complexity, having all the code live inside the main function becomes increasingly complicated. A function is almost like a mini program that we can write separately from the main program without having to think about the rest of the program while we write it. This allows us to reduce a complicated program into smaller, more manageable chunks, which reduces the overall complexity of our program. Reusability. Once a function's written, it can be called multiple times from within the program. This avoids duplicated code, don't repeat yourself, and it minimizes the probability of copy-paste errors. Functions can also be shared with other programs, reducing the amount of code that has to be written from scratch and retested each time. Testing. Because functions reduce code redundancy, there's less code to test in the first place. Also, because functions are self-contained, once we've tested a function to ensure it works, we don't need to test it again unless we change it. This reduces the amount of code we have to test at one time, making it much easier to find bugs or avoid them in the first place. Extensibility. When we need to extend our program to handle a case it didn't handle before, functions allow us to make the change in one place and have that change take effect every time the function is called. Abstraction. In order to use a function, you only need to know its name, inputs and outputs, and where it lives. You don't need to know how it works or what other code it's dependent upon to use it. This lowers the amount of knowledge required to use other people's code, including everything in the standard library. Effectively using functions. One of the biggest challenges new programmers encounter, besides learning the language, is understanding when and how to use functions effectively. Here are a few basic guidelines for writing functions. Groups of statements that appear more than once in a program should generally be made into a function. For example, if we're reading input from the user multiple times in the same way, it's a great candidate for a function. If we output something in the same way in multiple places, that's also a great candidate for a function. Code that has a well-defined set of inputs and outputs is a good candidate for a function, particularly if it's complicated. For example, if we have a list of items, oh my god, it's the eagle and wolf, I'm sorry, I had to stop once I recognized it. If we output something in the same way in multiple places, it's also a great candidate for a function. Well, I just reread that. Code that has a well-defined set of inputs and outputs is a good candidate for a function, particularly if it's complicated. For example, if we have a list of items that we want to sort, the code to do the sorting would make a great function, even if it's only done once. The input is the unsorted list. The output is the sorted list. Another good perspective function would be code that simulates the roll of a six-sided dice. Your current program may only use that in one place, but if you turn it into a function, it's ready to be reused if you later extend your program or in a future program. A function should generally perform one and only one task. I like that. When a function becomes too long, too complicated, or too hard to understand, it can be split into multiple subfunctions. This is called refactoring. We talk more about refactoring in lesson 3.10, finding issues before they become problems. Typically, when learning C++, you'll write a lot of programs that involve three subtasks: reading inputs from the user, calculating a value from the inputs, printing the calculated value. For trivial programs, less than 20 lines of code, some or all of these can be done in a function main. However, for longer programs or just for practice, each of these is a good candidate for an individual function. New programmers often combine calculating a value and printing the calculated value into a single function. However, this violates the one-task rule of thumb for functions. A function that calculates the value should return the value to the caller and let the caller decide what to do with the calculated value, such as call another function to print the value. Okay, and that was 2.6. Whoa! The mini truck is back. I don't know what the hell this is. We have ad blocker on, but that one got through. And it looked like a fake ad. Like, what was that? 2.7, forward declarations and definitions. Just want to see how long this one is. Oof, quite a lot. Quite a lot of questions too. Oh, it's only been an hour. I'm like, it's late. Nah, we can do this one. I'm like, I'm sick, so I wanna. But I did the black lipstick, you know? What are these exactly? You have 5. These are long. Each of the following programs state whether they failed to compile, failed to link, or compile and link successfully. If you are not sure, try compiling them. I'm just thinking it through. I don't want to push too hard. You know what? I think we will stop here because this feels like a really beefy one to come back to. And I feel like we kind of just end cap functions. I feel bad that maybe last stream we should have done that last part because that would have been the whole functions part. Because now we're doing forward declarations and definitions. I'm like, tomorrow. Hello? What even fell just now? tomorrow, I'd like to come back, tell you some Lands of Lore. Also want to do some more Silent Hill practice this Friday. I think we need to do an all-day stream Saturday. Tomorrow will be 1 week with this virus I have, so it'll be gone by Saturday, you know? I think we need to call it, make it short, this one. We're sick, you know? But we made some new friends, you know? Let's see who we're rating. Oh, wait. No raid. We gotta type. Let's see. It's just, honestly, if I don't mind reading, but if I want the quiz questions. So I was a little upset that there was just one quiz question. We got it wrong. I feel like I want a lot of those questions, but I want to like really be able to tackle it. Whereas right now I'm like, but I have to go to bed. If we do Saturday, I can start early. We can go all day, take lots of breaks, and just be snuggly about it. I think this is a good warm-up, good way to like get back into streaming again. I didn't want to be away. But honestly, with my new medication, this is the first time that like I've been able to take a break from streaming and not feel like, oh my god, I'm not gonna, like I'm starting the cycle again of me not doing what I want to do. I knew like I will come back. I just need to get better. Because I am honestly loving streaming so much right now. I want to stop looking at the keyboard. I don't know. I can't stop. When I do stop, I feel better. Like my eyes feel calmer. Like they're not like darting back and forth like 21 was our time last. Set. Ah! -1. Wow. 23. 2. I think this is really good to do. Start of the stream, end of the stream. Alright. Let's figure out who we're rating. Little baby stream. Get back into it. So many people online right now. On a Tuesday. Oh, but I know. Give me a moment.
Something.
With these ads. Toothless. How to Train Your Dragon ad. Okay, we will be rating Abby. We love Abby. Oh, thank you so much. Thank you for joining. We will be back Saturday. And I am feeling better. Thank you so much. And we'll just get better and better. We are going to be rating Abby. She's playing Silent Hill 2. looks like OG. So we're in for some cozy times. Yeah, I think I'm just gonna send you guys out. I'll see you guys tomorrow, and bye.